Okay, time to finish this review video. So we're going to finish the 22 through 31. Okay, number 22. It says, find the measure of angle B to the nearest tenth if cosine of B is 0.8926 and angle B is an acute angle. Okay, remember, if I'm ever wanting to find an angle, this is when I do the inverse. So if I want to find angle B, then I need to take the inverse of cosine and then type in the 0.8926. So if I want to find an angle, this is when we do the inverse. So if this would have said sine, this would be inverse sine. If this said tangent, this would be inverse tangent. Okay, so I'm going to type that in my calculator. So I'm going to go second cosine 0.8926, and it wants me to round to the nearest tenth of a degree. So this would be 26.8, and that's degrees. Sorry, I started to lose my voice between the first video and this second video, so bear with me. Okay, 23. It wants us to find x. I don't know what these angles are, 30 or 60, 45, 45, but I do have a right triangle, and I do know two sides, so I can use Pythagorean theorem. So which one's the c? The x. So it's going to go 38 squared plus 13 squared equals x squared. Okay, this is easy. In my calculator, I can put in the 38 squared plus the 13 squared, which makes 1613. I can't leave my squared there, so I'm going to square root both sides. And if I square root 1613, it gives me this for an answer, and it does tell me to round to the nearest tenths, which is why I wasn't even worrying about simplifying the radical. So if I round to the nearest tenths, that would be 40.2. Pretty easy. Okay, number 24. Okay, I'm looking for x. This isn't a 30, 60, 90. It's not a 45, 45, 90. I'm going to have to use my trig. So let's see if we are given a hypotenuse. Do I have the hypotenuse in this picture? Nope. So then I come to my angle in the triangle, the angle that's not the 90. What would you label the x? Opposite. And what would you label the 18.5? Adjacent. It's right next to it. Okay, let me put my little memory device up here. SOHCAHTOA. So whenever we have the O and the A, the opposite and adjacent, we use tangent. So this is going to go tangent of whatever the angle is, 59, equals opposite over adjacent. So opposite over adjacent. So x over 18.5. My goal is to solve for x. So if I want to get rid of the division of 18.5, I just multiply both sides by 18.5. The 18.5s cancel out, and all I have to do is put this in my calculator, and I'll have my answer. So I'm going to put in 18.5 times the tangent of 59. And what's it say to round to? The nearest tenths. So that would be 30.8. And that's my x. So 30.8. Okay, 25. When I look at my triangle, I can see I'm working with a 30, 60, 90. So I'm going to start my labeling process. Across from the 30, I label with x, which is already there. Across from the 60, I label with x square root of 3. And across from the 90, I label with 2x. Because there's a number there, let me put equals 2x. Okay, I need to know what x is. So I am not given x, so I need to solve this equation. So I would divide both sides by 2. And I know that doesn't come out pretty, so you can go ahead and give me a decimal. And that would give x equals 3.5. So that's what x is. So since this is x, this side would be 3.5. So I'm going to put that right here. And then this side says it's x square root of 3. And I know x is 3.5, so this side would be 3.5 square root of 3. And that's what side y is. So where side y is, I'm going to put 3.5 square root of 3. Okay, these next problems, we have to draw pictures. So that can be a little confusing. I just want to remind you of a few things. Angle of elevation is when you're looking up. Angle of depression is when you're looking down. Okay, here we go. A person standing 30 feet from a flagpole can seek the top of the pole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground. Find the height of the flagpole to the nearest tenth of a foot. Sometimes I have to read these several times, so don't feel bad if you have to too. Okay, so we've got a person standing 30 feet from a flagpole. So I'm just going to draw a person. They're standing 30 feet from a flagpole. So let me just put a flagpole over here. And they're 30 feet from the flagpole. So I know this distance down here is 30 feet. Okay, it says that they can see the top of the pole at a 35-degree angle of elevation. That means they're looking up at the pole. So this person is looking up at the pole. And then it says that the person's eye level is 5 feet from the ground. Okay, so here's their eye level. I'm going to end up making a triangle here. They look up at the flagpole, and that angle that they look up is 35 degrees. And it says the person's eye level is 5 feet from the ground. That means this distance from their eyeball here to the ground is 5 feet. And I want to find the height of the flagpole to the nearest tenth of a foot. So I want to find this whole length here. Well, I already know this length right here. This length would be 5, because it's 5 over here. So if I can find this length right here, and then add these two together, then I'll know the height of my flagpole. Okay, remember this bottom piece is 30 because I'm 30 feet from the flagpole. So let me put a 30 right here. Okay, we're going to zero in on this triangle. So just focusing in on this triangle, are we given a hypotenuse in this picture? Think about where your right angle is. My right angle's here. There is no hypotenuse. Okay, so let's go to the angle we know about. The 30 would be right next to it, so 30 is adjacent. The x is all the way across from it, so x would be opposite. What do you use when you have an O and an A? Tangent. So it's tangent of the angle. Tangent is opposite over adjacent. So opposite over adjacent. My goal is to solve for x. So to get rid of division of 30, I'm going to multiply both sides by 30. Those 30s will cross out, and I just need to put this in my calculator. 30 times tangent of 35. Okay, here I go. So 30 times tangent of 35, and 21, even 21.0 rounded to the nearest tenths. Now keep in mind, that's just this distance right here. So if I want to know the whole height of the flagpole, I need to add the 21 to the 5, and that's going to make 26 feet. And that's my answer. So angle of elevation is looking up. Angle of depression will be looking down. Okay, let's keep going. 27. A forest ranger looking out from a ranger station can see a forest fire at a 35-degree angle of depression. Okay, so he's looking down. Okay, so we've got a forest ranger, and he's looking out of a ranger station at a fire. Okay, so here I've got this ranger station, And this person, here he is looking out straight, and then he looks down at this fire, and the angle that he looks down, it says, is a 35-degree angle of depression. It says the ranger's position is 100 feet above the ground. So he's up here, so this distance is 100 feet above the ground. And then it says, how far is it from the ranger station lookout point to the fire, rounded to the nearest tenth of a foot? Okay, so I want to know the distance from where he is to the fire, so I'm looking for this, which is X. Okay, I'm going to go ahead and finish off this triangle. Now, I've seen this done differently in the different classes. In my class, I know if this is 35 degrees, this one right here is 35 degrees. And then I can zero in on just this triangle right here. But a lot of the other classes, I've seen them go ahead and make a triangle here on the top also, and know that this piece is 100, and then work with this triangle, which is fine. I can do that also, or I can work with this triangle, whatever you're comfortable with. Okay, in this picture, am I given the hypotenuse? Yes, the hypotenuse is this X right here. And then if I come to the angle in question, what's the 100? The 100 is opposite. So what do we use when we have an O and an H? We use sine. Okay, so it's sine of the angle, which is 35, equals opposite over hypotenuse. So opposite over hypotenuse. Okay, I can't leave that X in the denominator, so I'm going to multiply both sides by X. And then I'm left with X times sine of 35 equals 100. If I want to undo this multiplication here, I'm going to divide. So I divide both sides by the sine of 35. And then I can simply just put this in my calculator. Now, if you were taught to solve this problem by setting up a proportion, you can do that as well. No big deal. Okay, so let me type this in. I've got 100 divided by sine of 35, and that makes X approximately, and what's this say? Nearest tenth, 174.3. And of course, this is in feet again. Okay, number 28. Sorry about that. It says a plane takes off and travels 25 miles west and then makes a right turn to the north. He then travels another 42 miles. How many miles is he from his starting location to the nearest tenth of a mile? Okay, so the plane takes off and it goes 25 miles west, makes a right turn to the north, and then travels another 42 miles. I want to know how many miles he is from his starting location. So this is where he started, this is where he is now. I want to know the distance. What's this look like to you? Pythagorean theorem. Okay, so it's going to go 25 squared plus 42 squared equals x squared. And I do get a round, so that's awesome. I can make the calculator do all my work because I'm going to round it. So in the calculator, I'm going to put in 25 squared plus 42 squared. And when I get that answer of 2389, the next thing I want to do is get rid of the squared. So I'm going to square root both sides. So in my calculator, I'm going to take the square root of 2389. And if I read 8.9. And this is miles. Yay! We just threw in a Pythagorean theorem problem. Most of you seem to like those. Okay, 29. A 16-foot ramp makes a 30-degree angle with the ground and the top of the loading dock. How high is the ramp and how far is the ramp from the base of the dock? Okay, think about what ramps look like. So here's my 16-foot ramp, and it makes a 30-degree angle with the ground. So here's the ground. So this is the 30 degrees. I want to know how high is the ramp. So I'm looking for how high is the ramp. And then I also want to know how far is the ramp from the base of the dock. So I'm also going to look for this distance too. So first let me find x, and then I can worry about finding this down here. So right now, do I have a hypotenuse? Yes, the 16 is a hypotenuse. If I go to the 30-degree angle, x is opposite. So what would I use here? I would use sine. So it goes sine of 30 equals opposite over hypotenuse, so x over 16. If I want to get rid of my division of 16, I'm going to multiply both sides by 16. And then I'm just going to put that in my calculator and I'll get my answer. So 16 times the sine of 30. So 16 times the sine of 30. And that makes 8. Okay. Oh, you know what I just realized I probably could have done? This is a 30, 60, 90 triangle. I don't have to do trig if I don't want to. Now, I started off doing trig, so I can keep doing trig. Or I can know that this is a 30, 60, 90 and start labeling with the x, x squared root of 3, and 2x. It's kind of up to you how you want to do it. It doesn't really matter. So let me just try the 30, 60, 90 thing for a second. Across from the 30, I label with x. Okay. Across from the 60, which would be this right here, I'd label with x squared root of 3. And across from the 90, I label with 2x. Well, I already know x is 8, so if I want to know this bottom distance right here, I just put 8 in that x, and it would be 8 square root of 3. And this is all in feet. So 8 feet and 8 square root of 3 feet. I think that's one reason why the problem didn't tell us to round, because this happens to be a 30, 60, 90 triangle. I didn't catch it, so I started just using trig, which is fine because I can do trig all the time if I want. But because it's a 30, 60, 90, I can go back to our old labeling process. Okay, number 30. Find the angle of elevation of the sun when a 6-meter flagpole casts a 17-meter shadow. Okay, so here's my flagpole. It casts a 17-meter shadow. And it says, find the angle of elevation of the sun when a 6-meter flagpole. Okay, so the flagpole's 6. And if I want to know the angle of elevation, I need to be looking up. So I'm looking up to the flagpole, and that's what I'm looking for. So that's going to be my x. Okay, do I have a hypotenuse in this picture? I don't. So let me come to the angle. The 6 would be opposite, the 17 would be adjacent, and I'm going to use tangent. So it's tangent of x. Tangent is opposite over adjacent, so 6 over 17. If I'm ever looking for an angle, this is when I do the inverse. So if I want to find x, I take the inverse of tangent of 6 over 17. So every time we're looking for an angle, we're going to do inverse. Calculator time. So inverse tangent of 6 over 17, and that makes 19.4, and what's it say? It doesn't tell me what to round to, so I'll just go ahead and round to the nearest tenths. 19.4, and I'm going to put degrees because we're finding an angle here. All right, last one. The perimeter of a square is 36 inches. Okay, so let me draw a square. Remember, I know all 4 sides are congruent. I know all 4 angles are 90 degrees. And it says find the length of the diagonal. Okay, so I'm looking for the length of a diagonal. Of course, I could have drawn the diagonal I'm drawing, or I could have drawn this one. Doesn't matter. Okay, if my perimeter is 36, what must all these sides be? What plus what plus what plus what makes 36? 9. 9 plus 9 plus 9 plus 9 makes 36. If I want to know the length of this diagonal, I can either do Pythagorean theorem, or I can know that since these 2 sides equal, this is a 45, 45, 90 triangle. Okay, let's label. Across from the 45, I label with x. Across from the 45, I label with x. And across from the 90, I label with x square root of 2. So x is 9. So what's this side? 9 square root of 2. And that's the length of my diagonal. And we're done here. Smiley face. I hope this makes sense. I hope you all do well with your test. Rewatch this video if you have to. Good luck.